Okay, can you see my screen? Boleh nampak tak screen ni? Okay, great. Okay, so now we're going to look at these examples here. Okay, so using the 7-segment display, okay, you're going to write a program to display number 0 to 9 continuously. Okay, so first, what you're going to do here is, okay, you need to identify what is the code or what is the value that you need to send to your 7 segments, okay, in order to count from 0 to 9. Okay, so you need to identify how based on these 7 segments. Okay, you already learned about the 7 segment. Okay, and then you need to find out what are the values that you need to send out in order to display number 1, 2, 3 until 9 to this what you call here, to this 7 segment. So what you're going to do here is, okay, first, okay, you have the Atmega 32. So this is your Atmega 32, and then next, okay, you're connected your Atmega 32 to the 7 segment display. Okay, so you have the 7 segments display. Okay, in this case here, okay, we are using the common cathode. Okay, so all the cathode is connected to ground. Means that if you give 1, then the 7 segment will turn on. If you give 0, then the 7 segment will turn off. Okay, so let's assume that, okay, this 7 segment is connected to port B. Okay, so before we do the program, okay, so what you need to do is you need to figure out lah, okay, what is the value that you need to send to this 7 segment in order to display these numbers here. Okay, if you're going to display 0, okay, so this would be your 0, okay, and then the LED that need to turn on is A, B, C, D, E, F, G, and H is turned off. Okay, so you need to find out what is the value here. A, B, C, D, E, F, G, H. Okay, since this is a common, what we call here, common cathode, so need to send 1 in order to light this LED and send 0 to turn off the LED. So this is the value. All right. So you convert it to hexadecimal, then you will get 3F to display number 0. Okay. And what about to display number 1? Okay, to display number 1, so the LED that you need to turn on is only B and C. Okay, so B, C turn on, the rest is turned off. And you will get the hexadecimal for this value, which is by using the 8-4 to 1 method. So this is 0, 6. So this is 1. Sorry, this is a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so this is the value lah. Okay, that you need to send out. But this one here, okay, this is by using the assembly language. Okay, now you're focusing on the C programming. Okay, so what you're going to do is, okay, first, before we start the program, what you're going to do is you need to include the library or to include the file, which is this file here. Okay, so include avr/io.h. Okay, so this is the first file that you need to include. Okay, since this one here, okay, this 7 segment, okay, since you're going to send a counting value from 0 to 9, okay, and in order to make sure that you can see the what we call here the patterns, okay, the numbers, okay, so you need to generate a certain delay. Okay, so in order to generate a certain delay, okay, you have 2 options for the delay. Okay, the first option by using a delay function. Okay, that is available in the C program. Okay, and the second one here by using a timer programming. Okay, so this is two way to creating a delay. Satu, kita buat guna function. Okay, that is available. And the second one here by using the timer programming. Okay, for the timer programming, you will learn this one here in the next module. Okay, so now we are focusing on this delay function. Okay, to use this delay function here, what you're going to do is, okay, mula-mula, okay, you need to define your CPU. All right, if your CPU 1 megahertz, so you need to define F underscore CPU and then 1 million. Okay, so this is the CPU speed or your external speed. Okay, and then you need to include this file util/delay.h. Okay, so if you're not including this file here, what happens is you cannot use this delay function. Okay, the delay function that you're going to use is a underscore delay underscore ms. So this delay here in milliseconds. Okay, because it is a ms. Okay, if you're going to create a smaller delay, okay, or okay, you can use the US, which is a microsecond. Okay, so this is a milliseconds. Okay, and then you can put any value inside here. Okay, so here, after you include all the header files, define the CPU speed, then after that, we started with our main program. Okay, so int main void. So this is what you're going to do inside here. Okay, first, since this 7 segment is connected to your port B, so what you're going to do? So you need to initialize your port B so that your port B become an output port. How to do that? Okay, by sending one to your DDRB. Okay, so since all the port B is connected to this 7 segments display, so the value that you're going to send to your port B is DDRB OXFF. So what happened here? All this port B here become your output port. Okay, so this is to initialize, okay, the port B so that the port B become the output ports. Do you have any switches here? In this example, no switches. So then after that, okay, we started with a while loop. While one, why while one? Because you're going to do is continuously. Okay, so everything this number here should be put inside of this while loop. Okay, so first, okay, we just use a simple programming. Okay, send a value to your port B, call a delay, send another value to port B, call a delay. Okay, this is the simple. Okay, this is the easiest way lah. Okay, to do this, to send, to display counting from 0 to 9 to your 7 segment, or you can use a array. Okay, which is there is another way lah to do it. Okay, so in this case here, I just show you, okay, the easiest way, okay, to do a counting or to display the number from 0 to 9 to your 7 segment. Okay, first, okay, first, what you're going to do, we need to display number 0. So port B equal to OX3F, because this is for the number 0. So you send this value here to your port B, and then automatically this value here, okay, the 3F as we already derived earlier. Okay, so this is the value of the 3F if you convert to binary. And what happened here, this LED will turn on accordingly, okay, depending on this value. Okay, so here, so this is a number 0, and then you call a delay, which is 2000, means that 2000 millisecond, not 2 millisecond. This is a 2000 millisecond, which is equal to 2 seconds, right? And then send the second value. Okay, the second number, which is you're going to display number 1. So this is the value to turn to derive a number 1 to your 7 segment. Call another delay, and this is number 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and then it will keep repeating because this is a while loop with a value with a condition 1, means that it's always true. Okay, so next example, okay, you are going to write an AVLC program, okay, to get a byte of data from port B and then send it to port C. Okay, so you have a Omega 32, right? So now what you're going to do is to get a byte of data, okay, to get a byte. What is a byte? Means it is a 8-bit. Okay, 1 byte, 8-bit. Okay, data from which port? From port B. Okay, means that this port B, okay, let's D is a port B. Okay, this port B here is connected to switches. Okay, why? Because get a data means that this is a switch and send it to port C. Okay, then kamu hantar ke port C. So this port C here, so let's this is a port C. Okay, and this port C here send means that this is an output. All right, get the data from this switch and send it to port C, which is okay. Let's assume that this is connected to LEDs. Okay, so this is 8-bit as well. Okay, so what you're going to do here is, okay, whatever data that is read from this port B will then send it to this port C. Okay, so what you're going to do here is, okay, macam biasalah. Okay, so you include this header file here. Okay, standard avr/io.h file and started with your main program. Okay, and then here, okay, initialize your port B and port C. Okay, since port B is connected to switches. Okay, so why not? So what happened here? Okay, so that's why you put a DDRB equal to 0. Okay, you're going to make your port B as an input port, and this port C here, you're going to send the value here. So make this port C as a output port. So DDRC OXFF. Okay, and then before that, okay, before we started with the send the data, okay, under the while loop, what you're going to do here is, okay, another one here is make sure that a port B equal to OXFF. Kenapa? Why we need to do to insert this what you call this code here? Kenapa nak tambah code ni? Anyone? Okay, because you're going to enable the pull up resistor. Okay, so every time, okay, you connected your port to a switch, okay, make sure that you enable the pull up resistor. Okay, and then after that, while one, okay, so this one here, okay, so we using one variable called temp, okay, to temporarily store a data before we send it to the port C. Okay, means that the value coming of port B, okay, put it to your temp, okay, which is a temporary variable, and then after that you send it to the port C. Okay, before you using this temp here, so you need to declare, okay, so declare this temp as a unsigned char. Okay, so next what happen here is temp equal to pin B. So in this case here, okay, whatever value from this pin B will go to your temp, and after that port C equal to 10, okay, means that this value temp will be sent out to the port C. Okay, and sometimes you can do something like this, port C, okay, sama dengan pin B pun boleh. Okay, but to be safe, okay, better we use something like this. Okay, put it to the temporary variable, and then after that send it to the port C. Right, any question for this example 710? Ada soalan tak before we move on to the next slide? Okay, if no question, then we go to this example here. Okay, you are going to write an AVLC program, okay, to monitor bit 7 of port B. Okay, Lucas. Okay, you Lucas your Omega 32. Okay, so you have a PB7. Okay, and then the keyword here is monitor. Monitor means that you're going to check either your switch is pressed or not. Okay, that is a monitor. Means that the PB7 is connected to your input. Okay, if it is 1, okay, make bit for port B as an input. Okay, so you have a PB4 here. If the value here is 1, what happens is PB4 sama dengan input. Okay, you make it as an input. And else, okay, change it as a output. Okay, if it's 0, okay, if the value is from PB7 is 0, then make it as a output. PB4 equal to output. Okay, so you have one port here, which is a port B. Okay, and then this port B here, okay, the value of this port, especially at the PB4, is determined by the switches. Either it's a press or not. Okay, so what are you going to do? Okay, macam biasalah. Okay, include the avr/io.h file and then start with your main program. Okay, and this one here, first we need to initialize. Okay, initialize the PB7 as an input port. Okay, so you can do something like this: ddrb equal to, okay, ddrb and with this value. Okay, so this is inverting, okay, bit 7. Okay, you invert, so now it becomes 0, and you AND-kan dengan your ddrb value. Okay, whatever the current ddrb value, you AND them, and then what happen here is automatically bit 7 here will be 0. Or, okay, you can simply write something like this, pun boleh 0B 0111111, and then you AND 0, 1, 2, 3, 4, 5, 6. Okay, and with the ddrb. Okay, so this we call it as a masking lah. Okay, kenapa masking? Because we are only going to change PB7. Okay, the rest of the pin, okay, PB6, PB5 until PB0, the value is not affected. Okay, because you end with 1. Okay, whatever value you end with 1, you will get the same value. Okay, if you end with 0, so what happen here? You automatically clear that bit. Alright, so next, after you initialize your port B7 as an input, next, okay, lupa pula kat sini. Okay, make sure that you initialize lah, you enable lah your port B. Okay, bit 7 enable the pull up resistor. Okay, you can simply put 0B 1 0 0 0 0 0 0 0. Okay, you can simply put something like this, or ataupun you can, if you don't want to change any value inside of this port B, started from bit 0 to bit 6. Okay, if you're going to what we call here, not to change this value, okay, inside of the port B, okay, you can simply write something like this: port B sama dengan port B, okay, whatever current value of your port B, or with 0B1000000000. So only this bit, okay, will be set. Okay, only bit 7 will be set, and the rest of this bit, okay, whatever value you all with 0, you will get the same value. Right? So this is another masking. Okay. Okay, so this is masking for the to clear. Okay, you need to use the AND here, logical AND, and this is a masking if you're going to set. Okay, use the OR. Okay, and then we started with a while loop. Okay, and going to check the PB7. Either it is pressed or not. It is give a logic 1 or 0. Okay, so what you're going to do is pin B and with this bit here. Okay, and then if it is yes, what happened here is, okay, you need to make your DDRB4 as a input. If not, make your DDRB4 as a output. So you can simply put DDRB sama dengan DDRB and give this value here. So automatically your port B now become an input. Or if the value here is 0, so what happen here, you make it as an output. So DDRB sama dengan DDRB, use use the logical OR, and D is the bit that you're going to set. Okay. Okay, so another example. Okay, we have a lot of examples here. Okay, so write an FVRC program, okay, to get a status of bit 5 port B and send it to bit 7 of port C continuously. Okay, sama jugalah. Okay, you have lukis dulu. Okay, you draw your Omega 32. Okay, then you have a PB5. Okay, let's see it's a PB5. Okay, get the status. Okay, means that this PB5 is connected to switches. Okay, and then send it to the bit 7 of port C. Okay, and then you have a PC7. Okay, whatever value that you get in this PB5, you're going to send it to PC7. Okay, so what are you going to do? Okay, you draw this circle here, so you know that PB5 you need to make it as an input port, while PC7 make it as an output port. So you started with your program. Okay, start with this, include this AVR header file, and under the main program here, you can simply write int main port. Okay, initialize dulu. Okay, initialize your input output port. Okay, so DDRC sama dengan 0P. Okay, PC7. Okay, put 1, 0, 0, 0, 0, 0, 0, 0. So this is what? Or, okay, so if you put something like this, what happened here is PB7, you make it as an output port, while the rest you make it as a input port. Or if you're going to make sure that, okay, this bit here, okay, this 7 bits here is remains. Okay, the value is remain, not change. So what you can do is you can do a masking. Okay, by simply write DDRC sama dengan DDRC, and then since you're going to set, okay, we use the OR 0B 1 0 0 0 0 0 0 0. Okay, so only this bit will be set. The remaining of the bit, okay, the value here will be follow the previous value. Okay, or kalau tak nak buat something like this, okay, because you seem that is boring to write something like this, okay, you can use this this way of coding, which is, okay, one. Okay, so what is the meaning by this one here is means that, okay, shift 1 to the left, how many times? 7 times. Okay, you have values 1. Okay, 1, change it to the binary, you will get this value here. Okay, so this is a value. You change it to the binary. And then what happened here? You're going to shift it to the left 7 times. So this one here will shift to the left 1, 2, 3, 4, 5, 6, 7. Okay, so it will become here. Okay, what about the rest? The rest will be filled up by 0. Actually, it's similar lah, sama dengan this value. Okay, and then else port C. Oh, sorry, kita baru buka dekat sini ya, DDRC. Okay, so you already made your DDRC. Okay, PC7 as an output port, and then make the PB5 as an input port. So DDRB sama dengan 0B 0, sorry, not 0, 1. Okay, 1, 1, 0, 1, 1, 1, 1, 1. Okay, so only PB5, you set it as an input port, the rest you make it as a output. Or you can simply write down something like this, DDRB sama dengan DDRB by using a masking. Okay, we use an N. Why N? Because we're going to clear at this bit. Okay, so use an N 0B11011111. So only this bit will be clear. The rest of the bit, okay, the value will remain of no change. Okay, so you already initialize your port B as a PB5 as an input port. And next, okay, don't forget to enable the pull up resistor at this PB5 here by sending this value 001000000. So PB5 enable pull up resistor. Okay, and then after that we start with a while loop lah. Okay, because we're going to monitor. Okay, so put a while one lah, continuously monitor. Okay, if pin B, okay, and with this value, okay, if it's true, so what happen? Okay, you're going to set your, okay, you're going to give the value of your PC with 1. If not, then what happen? Okay, clear the bit server of port C to 0. Okay, actually okay, this is another way lah to do it. Or you can simply write something like this lah, because you're going to get the status of PB5 and set it to PB7. So what you're going to do here is you just simply write something like this lah. Okay. Can we do that? Port B5 is it? At port B5 sama dengan okay, we cannot do that. Okay, so only something like this. Okay, unless you have the whole port here is connected to switch, then you can simply write port B sama dengan pin, port C sama dengan pin B. But now cannot. Cannot. I think can lah, because okay, so I think this. Okay, you can use this. Okay, if you don't want to use this, okay, you can simply write port C sama dengan pin B. So what happen? Whatever value that is pressed or not pressed from this PB5 will be sent out automatically to your PC. Oh, cannot because this is PB5, this is PC7. Cannot. Okay, because the bit here is different. So you cannot do that. Okay, so cannot use this one. Okay, you need to follow this lah. Okay, which is if, okay, let's say you put something like this, pin B, okay, sama dengan, okay, you're going to check whether this PB5 is pressed or not. Okay, you can put 0B001 00000. Okay, means that PB5 is pressed. Okay, it will give a logic 1. So what happen here is port C sama dengan, okay, you can send out 0B10000000. Okay, which is it will send 1 to your PC7. Else, okay, port C sama dengan kosong. Okay, any question up until here? Ada soalan tak? Okay, if no question, then we move on to the next slide. Okay, so this is a FVRC time delay. Okay, as I mentioned earlier, all right, there are three ways to create a time delay in FVRC. Okay, first by using a simple for loop. Okay, by using a loop, you can create a delay. The second one, which is using the predefined C function, okay, which is you can use the underscore delay underscore MF. Okay, so we have the predefined C function. Okay, so the predefined C function, you can use this underscore delay underscore MS or underscore delay underscore US for microseconds, and then AVR by using the timers. Okay, so this one you need to do your programming lah by using the timer. Okay, so let's look at the first one here. Okay, so this is by using the what we call here the for loop, okay, to create a delay. Okay, so in order to create this delay here, okay, you need to do a try and error lah. Okay, if you, for example, if you're going to create a 100 millisecond delay, okay, you need to do a try and error. What is the value that you're going to put here? All right, because first, what you need to do is you need to find out what is the cycles for each of these codes or each of these C instruction here, C lines here. Okay, and then after that you need to multiply and find out the, okay, so this instruction here will execute for how many seconds, for how many milliseconds, and then after that, okay, you can figure out what is the value that you're going to put inside of this for loop, okay, in order to make a 100 millisecond delay. So this is just a try and error, okay, to see whether you can grade a 100 millisecond delay or not. Okay, sometimes you cannot grade create exactly 100 millisecond, but you can create approximately dia, okay, hampir dengan 100 millisecond delay. And this is another way, okay, which is by using the C function, all right. Okay, in order to use this C predefined function, okay, you need to first define your CPU speed. Okay, what is the type of CPU speed that you're going to use? Is it 1 megahertz, 2 megahertz, 60 megahertz? And then include this header here. Okay, so this is important lah. If you not include this header here, so what happened here is after you write down this underscore delay underscore ms, the compiler will not know what is this function do. Okay, and third, then after that you can use this underscore delay underscore ms and put any value that you're going to use here. Okay, most of the time, okay, the maximum value inside here is 250 lah, okay, which is to generate a 250 millisecond. If more than that, okay, the compiler will automatically do it without your knowing lah. It will do it if you control lah, if you're going to do a 500 millisecond, okay, so you put 500 millisecond, by right the maximum is 250, but the compiler will create this 500 millisecond with a 200 will call this delay underscore ms 252 times inside of without you knowing, okay, but the delay you create is 500 milliseconds. Okay, and then so okay, so let's look at the Atmega 32 IO problems. Okay, so this is a list lah. Okay, a few problems that related to Atmega 32 IO. Okay, first is IO are scarce. Okay, which is you only have a 32 input output. What happens if you're going to put a sensor more than 32? Okay, for example, you have a 40 sensor. Okay, since your Atmega 32 IC only support up to 32 sensors at one time. So is it okay? Because you and then how you going to, okay, because you're going to use 40 sensors for your project. So what you're going to do, is it you're going to buy a new chip or you're going to do a modification? Okay, so that is a problem lah, okay, related to IO. Okay, not enough time to buy a micro P with a more IOs. Okay, case since your project requires you to use a 40 or 50 sensors, and ATmega 32 only support up to 32 sensors input outputs. So what happens is, you not enough time, because your project is the due date of your project is very close, not enough time to buy. So what are you going to do? So you need to do some modification in order to make sure that to expand your input output inside of your ATmega 32. Sometimes it's a compatibility issues, especially using assembly language. Why? Because some assembly language, if you use a from one compiler to another compiler, is not supported, or simply no budget. You have no budget to buy a new ICs. So what are you going to do? The solution is we can use the MSI devices, in order to expand the input and output. How to do that? So let's look at this slides here. How to expand your input output so that you can use more than 32 input output by using ATmega 32. All right, so MSI is a medium scale integrated circuit. It's a logic circuit that contains 12 to 99 logic gates in a circuit. You know that your MSI. So example of MSI is such as a multiplexer, decoder, latch, flip-flop, adder, and etc. So the MSI can be divided into three categories. So for the input, you can use this MSI as your input. First is a buffer, and then parallel in, serial out, and priority encoder. For the output, we can use a latch, either a level trigger or edge trigger latch, and SEEE, which is a serial in, parallel out. And if you're going to have a both, which is a bidirectional, you can make it as an input and output at the same time. You can use a bidirectional buffer and keypad encoder. So let's look at this buffer and latch. What this buffer and latch do? So MSI device, buffer is used to temporarily store a data while it is being moved from one place to another. So it have a isolated shared data bus, especially for the input into microcontroller, and it have only one control pin. The rest for the data, which is total of 9 pins. So this is, you have a buffer here. So this is an example of the buffer. So this one here, this is the control pin. The pin 1 is the control pin. All right, and then pin 20 and pin 10 is your, what we call here, this is connected to VCC, and this is connected to ground, and this is from pin 2 to pin 9. This is an input of the buffer, while pin 11 and pin 18, this is an output from the buffer. Why are we going to use this buffer? Because this buffer, if you use it wisely, you can increase number of input pin in the micro pin. So this is the important part lah. In order to increase the number of inputs, input ports in the micro pin, you can use this buffer here. So how to do it? So let's look at this example. You're going to increase the number of input port B, from 8 inputs to 16. How to do that? Previously, your port B only consists of, so this is port B, PB7, PB6, PB5, PB4, 3, 2, 1, 0. So this is your port B. Port B only consists of 8 bits. But now you're going to expand this port B so that you're going to connect to. Sorry. You're going to connect to. So this is. You're going to connect it to 16 switch. Okay, so this is a switch 0 and this is switch 15. How to do that? Okay, macam mana nak buat? Okay, in order to connect this port B, okay, before, because your port B only 8 bits, okay, now you have 16 switch to connect to your port B. So how to do that? Okay, you need to use a buffer. Okay, so how many buffer that you required? Okay, you need to have 2 buffers, right? So you have this buffer here. Okay, and the input of buffer is coming from here. Okay, so this is the input. Okay, we'll connect it to this. Okay, so this is input 7, input 0, and the switch 0 will connect it to SW0 lah, and output 0, and this is switch 6, switch 7 will connect it. Okay, this is switch 7 will connect it to your output 7. Okay, what about the down here? Okay, sama juga lah. Okay, you connected the input 7 to your PB7, and the rest of this pin here you connected to your buffer, and this is output 0, you connect to this one. Okay, and then here, okay, so this is a switch output 0, this is output 7. Output 0 here connected to switch 8, and this is connected to output 7 will connected to switch 15. Okay, so now you have 16 switches that are connected to your port B. Okay, and then bear in mind that, okay, your buffer have one control. Okay, this is a control. Okay, so this we call it a control 0 and control 1. Okay, so these controls here, okay, you sambung connect to your any port. Either you're going to use a port A, port B, port C, port A, port C, or port D. Okay, never mind. Okay, either of this port here. Okay, let's this one here we connect it to PC0 and this is to PC1. So why? Okay, so this control switch here, this control here, okay, will select which buffer that you're going to read the switches. Okay, either buffer 0 or buffer 1. Okay, so because this buffer is connected to the same port, okay, so that's why you need to have this controller, okay, in order to control or in order to enable which buffer that you're going to read the switch from. Okay, because only one buffer can active at one time. Okay, so here this is a buffer 1 and this is a buffer 0. Okay, so this you have the switches. Okay, you connected to this input of buffer, and this is another 8 switch connected to this buffer 0 here, and you have the control. Okay, sambung ke PC0 and this is PC1, and this output here will connect to your PB0 and PB7. This one also similar. All right, so now what you're going to do? So now we're going to do the programming. Okay, so how to read a value from this buffer. Okay, so how to increase the number of buffer from port B from 8 to 16. Okay, first, what you're going to do? So this is in the assembly language lah. Of course, we can write it in the C programming. Okay, mula-mula, what you're going to do is, okay, you need to initialize dulu. Okay, DDRB equal to 0. Okay, make your port B as a input port, and then make sure that you enable the pull up resistor. Okay, next. Okay, before that, okay, here, PC0 and PC1. Okay, make sure that you initialize this PC0 and PC1 as a output port. Kenapa? Because we're going to give this value. Okay, if you give 1, what happen? You will enable this buffer here, okay, to read the switch from here. If you give 0, this buffer will be disabled. Okay, so that's why DDRC sama dengan OX FF. Okay, I just simply make all the port C as a output port. Okay, now I'm going to read the first switches here from buffer 0. Okay, so this buffer 0, if you see, connected to PC 0. So what I'm going to do here is first, okay, port C sama dengan, okay, 0B00000001. Okay, so here, what happened? Buffer 0, you enable, and buffer 1, you disable. Okay, 0 and 1. Okay, you enable buffer 0, disable buffer 1. Okay, then after that, what happened here is, okay, you read lah whatever value. Okay, let's do is you put in temp lah. Temp sama dengan pin B. Okay, so read data from switch 0 to switch 7, which is this is a buffer 0 lah. From buffer 0, switch 0 to switch 7, and put it to the temp. Okay, so this is a temp A lah. I call it as a temp A. And then, next. Okay, now I'm going to read these switches. Okay, from switch 8 to switch 15. So what happened here? Okay, so I need to enable buffer 1, disable buffer 0. So port C sama dengan 0B00000010. So what happened here? Okay, buffer 1 enable, and buffer 0 disable. And next, read the, okay, then you read a value from your pin B. Okay, so temp B sama dengan pin B. And of course lah, dekat sini, okay, you need to unsign char, okay, and temp A and temp B. Alright, so you need to initialize lah. Okay, you need to define your temp A and temp B. So this is how, okay, to expand your input by using a buffer. Okay, make sure that the control is enable or disable lah, which buffer that you're going to use. Any question up until here? Ada soalan? Okay, if no soalan, so I think we'll stop here. Okay, next class, okay, we will continue with this piezo, okay, latch, okay, and this latch is very useful lah in order to increase the number of output points. Okay, and then after that, after we finish, okay, we'll continue with the timer programming.